And welcome back to the morning show. It's Wednesday, Wise Guy time, and our U of I physics professor Matt Sellen is back after a brief hiatus, back here for the new year. And speaking of the new year, talking about how the calendar works and the rotation and, how things align, basically.
And so I realized I was kind of silly last time because I'm running around with volleyballs and apples, and I have this really kind of cool model that I brought in from
still, it was cool when
work.
You pierced the apple with the pencil.
I felt very godly, you know.
That was awesome. You did a great job.
So this thing kind of, if we can get a shot of this model, what it does is it shows you what I talked about. So this represents the sun right here, and here's the Earth, and you can see that the axis of the Earth kind of tilts away from the sun, and as you go around 6 months later, the tilt of the Earth is still going in the same direction, but now is sort of toward the sun. So you see that the whole orientation thing changes, so that this would be for us summer, over here would be for us winter.
Gotcha.
And over on these sides, let me rotate it like this, when we're basically, the tilt is sort of perpendicular to the direction between us and the sun. These are the equinoxes. So we have the spring and the fall equinox are going to be like that. Okay, now, this model is not to scale at all because the
Earth's pretty big.
So the diameter of the Earth is about, I don't know, 8,000 miles, something like that. The distance between the Earth and the sun is 93 million miles.
Okay.
So it's about, if this were the Earth, really the sun ought to be 10,000 of these away. So if this were the size of the Earth, the sun would be on the other side of town someplace.
Yeah, that probably wouldn't fit in our studio.
No, not a bit.
Not a bit.
Okay, so anyways, the calendars were interesting, and people tried to figure out a way that the seasons wouldn't get out of phase. And so what the Egyptians, I said, they knew that there was they said there was 365 days in a year, and they had a very rational system. They had 12 months with 30 days in each, and 12 because that's how many approximately lunar things there were, right? But then they're missing that quarter day a year. So what happened is after 4 years, they'd be off by a day, which doesn't seem like much, but after 40 years, they'd be off by 10 days.
Right.
400 years, they'd be off by 100 days, and it would take only 700 and some years for the Egyptians. You know, if you started with January being winter, January would be summer.
Oh, okay.
Okay, so it would...
The seasons would be out of whack.
Yeah, the seasons would be all out of whack. And so this was something that worried people, and so, you know, the Romans, actually, Julius Caesar did a good thing back in, just before the birth of Christ. He said there shall be, 365 and a quarter days.
Okay.
Okay, and so he added that quarter day and the whole idea of leap years. You stuck an extra day in every 4 years. And so that was kind of something that he was advised to do, so he did that. And they had kind of weird months, though. They thought that odd numbers were lucky and even numbers were unlucky.
Okay.
So all their months had either 31 or 29 days, except for February, which had that 28. So
because of the quarter day, right?
Because of the So anyway, so that was kind of interesting. And then it wasn't until way later, so in the what was the date? I wrote it down. I'm pretty bad at this.
1582.
1582. I wrote it right there.
I can read.
That Pope Gregory VIII kind of got it more or less better or right, and he said, okay, well, really, we're going to have this leap year every 4 years, but we're even wrong by a little bit when we do that. It turns out that then you have too many days in there, and you have to take a little bit out. So that means what he said was, okay, every 400 years, we're going to cancel 3 leap years. So basically, the extra rule he added was that if you have a century year, so like, the year 100 or the year 200 or 2100, 2200,
Gotcha.
If that is not divisible by 4, then that year you don't have a leap year.
Oh, okay.
Okay, so you have these simple little rules, and then you're only wrong by a few minutes a year, and then it takes thousands of years for things to get messed up.
Get out of whack.
So we'll have to fix it again later. Yeah. But what I'll talk about when we come back again...
Triple shot today.
Yeah, isn't that fun?
It's awesome.
Okay, is that why actually things aren't exactly as simple as I said. It turns out that the length of the day is changing, and the way the Earth points is changing a little bit.
Okay.
Okay?
Very good. Well, we'll have that coming up in about 15 or so minutes. But if you have any questions for Matt, you can either send them to themorningshow@wci.com or his very own personal spiffy website. That's at wiseguy.net.
Very spiffy.
It is spiffy. I like it. We'll be back right after this.